Parallelogram was a special quadrilateral that had opposite sides parallel. A rectangle is a quadrilateral with 4 right angles. It is also a parallelogram. Okay, so a rectangle is a quadrilateral with 4 right angles. It's a parallelogram with 4 right angles. It's a special parallelogram. A rhombus is a quadrilateral with 4 congruent sides. A rhombus is also a parallelogram. Okay, so rectangle is just a quadrilateral slash parallelogram with 4 right angles. The reason I mention it's also a parallelogram is because every rule that's true for a parallelogram that we just did also works for rectangles. And a rhombus is a quadrilateral with 4 congruent sides. If I can draw that. Good enough. So all 4 sides are the same. So a rhombus is also a parallelogram that just happens to have 4 sides all the same instead of 2 and 2. They're all 4 the same. So this also follows all the same rules as a parallelogram. And finally, if a rectangle and a rhombus have a baby, that's not a square. You get a square. So a square has both 4 congruent sides and 4 right angles. Really? Okay. So a rectangle is a parallelogram. Or sorry, a square rather. A square is a parallelogram, a rectangle, and it's a rhombus. Here's where we are so far. Okay, we are in the world of quadrilaterals. Okay, so that's just any 4-sided shape. Okay. Now inside the world of quadrilaterals, you have like a neighborhood. Or like, okay, so like if this was the state of Florida, then this is the city of Orlando. And that would be the parallelograms. Okay, and we have special stuff. C11.1. Okay, so parallelograms have opposite sides that are equal, opposite angles that are equal, opposite sides that are parallel, diagonals that bisect each other, consecutive angles that add up to 180. We talked about all that yesterday. Now inside of parallelograms, you've got some neighborhoods. This is Orlando. This is like, I don't know the names of neighborhoods in Orlando, but this is one neighborhood in Orlando. This is another neighborhood in Orlando, and they overlap somewhere. So here I have rectangles. Here I have rhombi. And the overlap is squares. So everything in here, in these circles, is also in these 2 rectangles. And then this square is in both circles. Want me to go over it again? We had, okay, quadrilaterals is very broad. It's just 4 sides. When you get into parallelograms, we had all those special features, but they also have 4 sides. So they're 4-sided and parallel sides and opposite sides congruent and opposite angle, you know, all those things we talked about yesterday. Then rectangles you add and all the angles are 90 degrees. And then rhombi you add and all the sides are congruent. So you just add extra features each time. Okay, so the diagonals of a rectangle are congruent. It is a parallelogram. So the diagonals of, the diagonals of the rectangle will follow the same pattern as the diagonals of a parallelogram, but because it's a rectangle, we have one more feature. Okay, which is as we come across here to here, close enough. If I name this rectangle A, B, C, D, AC is going to be the same length as BD. Okay. Now, because it's still a parallelogram, this is the same length as that, and this is, oops, this is the same length as that, and this is the same length as that. That's still true. But in a regular parallelogram, these two lines are not necessarily the same length as each other. Then we get in a rhombus, which that is not a rhombus. It's a bad rhombus. Nope. So we have the rhombus, you know, where all these sides are the same. Well, a rhombus, the diagonals are at perpendicular lines. Now, it's still true, the same as with a regular parallelogram, that this length will be the same as this length, and this length will be the same as this length. But we get the added benefit of those being perpendicular. And so if we named this EFGH, EG is going to be perpendicular to FH. Then we have, hold on, I'm going to, the diagonals of the rhombus. So as I come through and I make my diagonals, it bisects the angles. So what that means is this angle is going to be the same as that angle, which is going to be the same as this angle, which is going to be the same as that angle. The reason being is this whole angle was the same as that whole angle. So then if I cut them in half, each of the halves are all the same as each other. And this angle is the same as that angle, which is the same as that angle, which is the same as that angle. So you get 4 and 4, all the same.
And they're side by side.
Yeah, because it's being bisected, so it gets cut in half. Whenever you bisect something, you're cutting it in half. So the next time you have to like, okay. Then the next thing we have, if a parallelogram has a right angle, then it is a rectangle. Here's how I know this is true. If this is 90 degrees right here, it's a parallelogram, which means that this is 90 degrees. That means this one's also 90 degrees. So that 90 degrees turns into this 90 degrees. So far, okay? Then I know that this angle and this angle over here add up to 180 because that's what we have, that thing that says angles on the same side add up to 180. So if this is 90, that one has to be 90 because 90 plus 90 is 180. And then because that one's 90, that makes this one 90 because angles across from each other match. So if one of them's 90, it forces all of the other ones to be 90. Has two adjacent sides congruent, then it is a rhombus. So let's see if I can do this. Nope. Oh, yes. Okay, cool. here's what happens. If this side is the same length as that side, those are adjacent, right? Well, because it's a parallelogram, if this side is this length, that makes that side that length. And if this side is this length, it makes that side also the same length. So these two sides make these two sides the same. So two sides next to each other being the same makes all four sides the same. This is basically every rectangle is a parallelogram, which means it has all the same traits as a parallelogram. You don't have to write this down. 4 right angles and congruent diagonals. Every rhombus is a parallelogram, 4 congruent sides, perpendicular diagonals, and they bisect each other. And squares are parallelograms that are both rectangles and rhombi. So, I am going to draw pictures for you. Oops, that's not what I meant to do. Rectangle. From the parallelogram, well, we already know these are all 90 degrees, so I don't need to mark those. This angle will be the same as this angle. And this angle will be the same as this angle. But we get something interesting because of the fact that they are 90-degree angles over here. This angle is also the same as this angle, which is the same as all of those. And these are also the same. And the reason this is happening is because we're getting isosceles triangles. Because what we had was that these, because it's parallelogram, they bisect each other. So those are the same, and these are the same, but because this length is the same as that length, they're all four the same. And then we still have that this side is the same as that side, and this side is the same as that side. With a rhombus, please turn into a rhombus. Thank you. Now, I don't know. The 4 sides are the same, but I don't know anything about like this angle compared to that angle. In my drawing, they look 90 degrees, but they're not going to be necessarily 90 degrees. But this will be 90 degrees. This is the same as this, is the same as this, is the same as this. These are the same as each other. They're all 90. So those are the same length as each other. These are the same length as each other. Not necessarily all 4 the same length, though. And then all of the outside lines are the same. Okay. Then finally we get a square, which has the properties of both. So you get a whole bunch of stuff that matches in a square. Okay. All 8 angles are the same. So they're all 45 degrees. Then this is also perpendicular because it's a rhombus. Then these lengths are all the same. And these lengths are all the same. So you can see squares get really special in that like everything matches. I should make this 3s. Sorry, I'm making these 3s so that you don't get confused that they match those. Okay. We want it to be a rhombus. This is going to be the same thing as what we were doing yesterday. I want this distance traveled from here to here to be the same as from here to here. If I were counting spaces, I'm going from 3 to 7, so I'm going 1, so that's 4, 5, 6, 7, so that's up 4. And then -2 to 1, so that's -2, -1, 0, 1, so that's over 3. Up 4 over 3. I'm counting spaces. I'm not drawing the graph paper, but I'm counting spaces. Just pretend that there's graph paper here, and I count spaces. I'd go up 4 and over 3. So now I want to get from here to here. I'm going to go 3 and 4 because I need it to be the same, right? So I'm at 6. If I count backwards spaces, 1, 2, 3, that's 5, 4, 3. So that's 3. If I'm graph paper. And then I'm going to go down 4, 1, 2, 3, 4, which would also put me at 3. So this point would be on 3, 3 if I drew it on the graph. Does that make sense? Pretend there's, graph lines. So same idea as yesterday. Exact same idea as yesterday. Is a rectangle. EDC. EDC. That's right here is 37. I want to find EDA. Well, this whole thing is 90 because it's a rectangle. So it's 53. So far, okay? Kinda, because we only have like 4 minutes left. It's a right angle because it's a rectangle. This part's 37. I want to find this part. The whole thing's 90. So I did 90 minus 37. HIJK is a rhombus. LKJ, that's this part right here, is 29. And I want to find HIL, that's this part right here. But from my picture on a rhombus, I know that this is the same as this, is the same as this, is the same as that. So far, okay? So if this is 29, that is 29. So far, okay? Okay. MNOP is a square. OQO is this length right here is 17. And we want to find this length right here. Well, all of these are the same. So if this one's 17, oh, sorry, I want to find the whole length. If this is 17, then this part is also 17. So the whole thing is 34. Okay, and I need to find a point D, so I'm going to put some graph paper on another sheet because, well, it's just going to be easier. First one.
-9, -5.
So I've got 2, 4, 6, 8, 9.
-9.
2, 4, 5. Okay, that's A.
B is -9 and 1.
Okay, 9, 1. Okay.
C is -4 and 1.
2, 4, 1. And I'm trying to find D. And it's supposed to be a square or a rhombus, a rectangle?
It is supposed to be a rectangle.
Okay. Well, you see how this is straight up and down and that is straight up and down?
It's more like a square.
It's going to go right here because it's got to match. Everybody see that? So there's D, and that is -4, -5. So I'd go 2, 4, 2, 4, 5. -4, -5. Okay?